Thank you, Kansa. Hi. Uh, Let me have a brief introduction on why we have to go for this. This PK-enabled system is essential. As we have been discussing for the couple of 2 decades, why the PK-enabled system has been taken up by the CCO office, and what are the achievements, and how the digital transformation has made with the strength of the CCO office, under the blessings of MATI. So when we talk about PKI, it's a secure system that defines the rules, policy, the procedure, the hardware and the software, which are required to manage and control the whole digital certificate. So that's the reason why the PK ecosystem been made very strong in this ecosystem for digital transformations. The PK facilitates secure exchange of electronic information for various networks and the applications. But what happens when it comes in the model of vulnerability? That is the challenge comes up. So as we all know, this Shor's algorithm, the factorization problem in the terms of integer factorization and discrete logarithmic problem in finite element and elliptical curves as well as in general class groups. So this motivates or this enhances the work of organizers as well as the CCA to move towards the post-quantum. So when we transform the digital signature from the classical method to the post-quantum, what are the challenges the system has, how to deploy it? So this, as a part of the researchers, you will be working in terms of the research, how to deploy, how to get into the activity. But as a CCA, so we have to think in terms of the deployment in the real world and how it has to be enhanced to the digital signature in terms of hardware implementation, software implementation, how it has to enhance my digital signing signatures because it's not too heavy to work it on. So how this transition moves, why NIST has come into the picture in 2016 to go for a competition, why this classical mode of operation is not sufficient to make the eco-environment too strong. The question is undefined. See, we are working in terms of quantum world. When the quantum world comes, what is it? We want to have a Atmanirban. We want to have our own self-resilience system. So under this criteria, the MATI, under the blessings of MATI, the CC office initiated this post-quantum work so that we should be ready with this, what the algorithm has to work. So as been, yesterday I've been hearing Dr. Anand Mohan's talk also, which I have been discussing about the complete ecosystem, how the hash-based digital signature is going to work. So every researcher started working. Where is the deployment? How do we deploy it? So that's a big challenge. So for those deployments, this is the main issue where the migration moves towards, and the researcher has to work on for the optimization of the overall architecture. How the architecture looks like. Now still, as of now, it's only a mathematical model. So when you go for the hardware implementation, again the real challenge works with that. So already CDAC Bangalore is started working on this platform under the guidance of CCA as well. So when we talk about this post-quantum, can you just move? Here. When we move about this, the initial stage, how the theory of the threat of classical computer works. So as we all know, the Shor's and Groves algorithm makes us to threaten the world. So this is vulnerable in terms of the integer factorization, the discrete logarithmic problems, whatever we are going to exist in the world is going to be vulnerable. What happens when the classical, the post-quantum can be implemented on classical computer? Yes, but the computation time, it needs more because of the key size, because we are not going to work on the key size, we are going to work on the kilobytes. The heaviness as well as the security levels keeps increasing. That's when the morning we have been asking one questions also during the talk from the CDAC Patna. So when the key kilobytes increases, how it has to be implemented on the platform and the classical computers as well. When it goes on the quantum computing, it's fast enough to handle. But when it comes for the deployment, the real change happens. So that's what, if we talk about this factorization problem difficulty, from exponential of to polynomial of the quantum computing, as well as the larger integer factorized, that's the latest factorization is 21. Initially the last which has been authorized is 15. So now it has been very difficult to authorize this integer problem is 21 in 2012. Till now this is the relief for the researchers to work on this platform. So again the threats in the asymmetric as well as when you go for the Grover's algorithm, we have a threats in the symmetric ciphers also. Symmetric cipher basically self-resilience in quantum world, but still if you talk about the side channel attack, in terms of brute force, it is vulnerable. When you talk about the side channel attack, still it is having the strength of the equity. So what this post-quantum is going to do with us? So it's a field of research developing a cryptography algorithm that can resist the attack from the quantum computer. So still now, how many qubits have been developed? What are the attacks has been done? Because the latest research which is worked on, it's still not relieved with a conflict ideas. The approach, so as we all know, it's a lattice based, it's a code based, the multivariate based, the hash based. So these are the different variable models where it has been working also, and it has its own complications as well as limitations. When we talk about this lattice based, how based on the computational problems associated with the lattice. And for example, it is working on the Kershaw diatheorem, as well as for the code base, it is MacLean's the problems which is related on the decoding problems, they are related to the error coding concepts. And when we talk about the multivariant as well as the hash base, so the approach that differs upon the algorithm which is insisting. See, every algorithm, every coding concept which is going to resist in the quantum world has its own plus and minus pros and cons. But how do you want to deploy for the digital signature? That's a big challenge. So every researchers keep on moving towards the architecture, the complexity as well as the optimization. So when this world comes into the picture, which is going to resist, till date the 2 decade the RSA is resisting, but still RSA is vulnerable in certain point of time, certain point of attack and threats. But still we are working because the PK is the best solution which the Indian ecosystem is having it. As of now, no record has been initiated that any digital signature is cracked. This is a 2 decades, nobody cracked my PK solution. Even you can crack your algorithms, you can crack your key systems, but brute force any other attacks. But within the ecosystem, no digital signature has been compromised. So this is the strength of the CCA. So this is where the ecosystem completely having the whole control over the systems. So the same whatever the thing, other algorithm which has, so this coming back to the NIST competition, how they initiated. They have started this activity in 2016. So it has been a 3 level of rounds has been completed, hopefully. So again in the 4th round, the type of cryptography, the course base, the key encryption module, the classical McClinchy, BIC, SQ, as well as the other different things have been shortlisted. When we talk about the 3rd round, the alternate candidates, so the thing is the lattice based as well as the code based, multivariant, and the hash based, which have been discussed yesterday also, the super singular elliptic curve and zero knowledge proof. So among this, which one I have to go for it? How the system has to move, how the system has to define my system, which algorithm I should move ahead. So that's again the complexity of the system which is going to integrate towards the world. How the world is moving forward. Whether they started working, yes, couple of globally people have started working, they are going to ready with the self-resilient systems. Are they integrated? No, because the global is cannot work on individual. If a border chaining country started integrating, since we have not integrated, it cannot be like utilized in the global browsers also. So every global has being ready with the system. When they say everybody has to handshake as well mutually recognize each other, and it has to move forward. So when we talk about the international efforts in the post-quantum standardization, the ETA, that is the European Telecom Standard, they are accepting the NIST outcome candidate. So as well as the ISO, so they have been working on the finalizing the post-quantum cryptography, their own algorithms, nothing published in the public domain. The IETF, that is Internet Engineering and Task Force, discussed to establish the working group for the transfer support of post-quantum. The proposal for specifying the identifier, basically where I'm talking about in the morning also. So these identifiers are very much essential to depend how the International Forum is going to accept my TLS and SSL certificate. Because every platform, every code signing certificate, the digital signatures, everything implicates upon the algorithm which I'm going to integrate. And when talking about the Japan, so they have been again the same thing, they have been working on to accept the post-quantum NIST competition outcome. They are going to use the NIST competition as many Japanese contributors. They have been using on the round 3 as a finalist. And going back to UK, so the National Cybersecurity Centers, the nodal agency, they support the NIST standards. So advised to wait for the standards to come out and finalize the product as per the algorithms. And China, they have still, they already come out with their own signature algorithm as well as their own key encryption module. So see, the other countries, the globally people have started, they have already finalized their own variant. So this is the angle where Indian ecosystem, our CCA office also started their own finding the variant for the country, so that we can start ahead to understand before understanding the concept of how to integrate the whole ecosystem. So as of now, the RSA 1496 is used for digital signature for us, as well as we have been competing with this web trust module, where the whole ecosystem requires the 1496 as well as 20B key size, as well as the critical path extension. So when I talk about this certificate, which is in the morning, we have been talking about how it has to be integrated in a hybrid model. So when I go for hybrid module, again, it's too heavy for a system to carry to a device or any IoT device. So the system is working on it, how it has been integrated. So this can be started by the different nodal agencies as well across the global, by the Google as well as Infineon, the chip which has been designed by the New Hope. Basically, they are the first post-quantum hardware chip they have been developed, but it is in a failure model. So again, the IBM is also working on the focusing on the lattice based, because they are these 4 different categories of post-quantum cryptographic based systems, which is going to resilience in the quantum world. That's why they are moving towards the factorization problems, which is very hard to break. So coming back, finally, to understand how the researchers has to move ahead, how it has to be integrated, how the digital signature is utilized in a real-time model by the certifying authorities. So it's like the closed box, it's a black box. Nobody knows how it is, they are signing the signature, how it has been used by the user. Basically, you'll be getting your token, DSA certificate, that's it. So what is the background in the PK ecosystem? How the signature is designed, used by any algorithm. Just I cannot replace the RSA with the post-quantum algorithm, right? So it has been a lot of implication has to be there. I'll call upon Anup to give the demonstration. So this will give you the brief idea how the signature is going to be signed, how the digital signature certificate has been shown, how the X certificate, it is formulated by using the CSR request, but basically the customer service request. So with this reference to this, we have taken a small demo with reference to this crystal diatheme signature. Correct? Over to Anup.
Okay, so first morning somebody was asking how to learn about PKI and something. So we have our portal.
To add upon this, this is a small CA setup module. It's a UIT system which is developed by SIDAC Bangalore itself. So they have been working on this for the last 1.5 years along with CCA office with all the inputs. They have made this portal. So this portal will show you the real-time application, how the deployment has been done, how the DSA is issued, how the user is going to use that certificate.
Okay. So, so this is our website pkiindia.in, where you can find all the related resources. So all the PPT videos, we are there on we are there on YouTube also. We have a YouTube channel where we can find all the tutorial videos related to PKI. Now coming on to this PQC tutorial, this is another website, learn.pkiindia.in, where you can learn about anything, hashing, symmetric key, asymmetric key operation, PQC, digital signature in classical using RSA. So everything is there. And this is hands-on. You just open it, run it, and you can learn about that. So for example, here I will show you about this PQC. So here you can select any of the algorithm, dilithium 2, 3, or 5. Then just click on generate. It will generate the key. So public key, private key.
To add upon, sir, actually Dr. Anand Magam was asking in the morning how the security level has been ensured in the certificate. So 235 is the different levels of security which has been enhanced or it has been identified in the crystal diagram depends upon the kilobytes. Okay, the increasing the size, again the security level increases, the more complexity increases. So that's why the three different levels have been utilized. All the algorithms has been integrated in this portal.
Okay. So, so after generation of the key pair, you can move on to certificate generation. So I can enter. Sorry. And then there are two ways. Either you can generate a self-signed certificate. So in that case, the certificate will be signed using dilithium itself. So I will just generate once and I will download the certificate. Second way is that I can generate using one CA which is on RSA. So I will generate CSR and that CSR will be signed by the CA. I can again download that certificate. Now we'll see both the certificates. So first certificate, when I open, you can see it say, you cannot see, I will tell you that a system level error occurred while verifying host because it is signed by dilithium which the system doesn't understand. So that's fine. Now the second certificate I will open. So here you can see that this is the system recognizes it. It only says that Windows doesn't have enough information to verify this certificate because the CA that has signed, it is also means our own CA, the system CA. So what I will do is, there is an option here on top to download the CA certificate. So I will download CA certificate, and then that CA certificate I will add to my trust store. Since morning we have been talking about trust store. So I will not talk about that. I will simply add it to the trusted root. So once the import is successful, now if I again open that old certificate, this time it simply says that this certificate is intended for all application policy, and it will also show the certification path. So that's the certificate generation process. Next part was the signing part. So I will just click on next. Here you can add one message, and then this is my private key which is already taken from when I generated. So I will simply say hi, click on generate digital signature, and at the bottom it will generate the digital signature. Now we'll go to next, and here already the message is already there and public key is already there, because for verification we need the public key. I will simply click on verify. It will say verified OK, but if I change anything in the message, even adding one space, it will say verification failure. I can again remove the space and click on verify, and it will say verified OK. So that's the small demo. That's all. Thank you.
No, the diagram when he signs up, it shows it's not possible because in the any browser forum, these routes, this algorithm is still not installed.
Hello.
Okay, even I cannot push it to the trust also because it doesn't identify, because the root path, whatever the RSA, ECC, whatever the existing algorithm which is already in the browser forum, it's only accepting it. Even if try to push it also in the trusted store. So as of now, the global is not moved towards quantum algorithm so that the browser, because it's a long process as you know, like it has to go for reference audit time, so it has to accept it in the Canada, they have to get reference seal. So completing those processes, it's a second stage. Now we have any signing signature, when you push it to the trusted store from the root, CCA root. So that is accepted now. So crystal diagram, as of now, I can show the signature as a demonstrator. I can able to generate a certificate. If you compile both the certificate, so the crystal diagram as well as normal, the classical one, you can see the lot of difference in the memory size, the computation time. So it's too heavy now.
Pandian, one my question like root is on the traditional RSA, and can we make CA certificates on
No, sir. The root,
PQC?
whichever the root certificate, it has to be there. It has to follow that same.
It's
traditional.
not a hybrid type of.
Cannot be hybrid.
Is there?
No, you should that, but it's not accepted.
So like our CCA root is RSA, so we can make PQC or post quantum user certificates or CS. Is it possible? Na?
Acceptance is not there.
So currently the system doesn't recognize that dilithium certificate. Just now I showed, but if you, but you can do,
But the
and that hybrid is also possible. That CA is RSA and client is on dilithium, or vice versa.
Acha, one thing more, like we have seen in the RSA algorithm, like private and public key sizes are fixed, like whatever you choose, 1024 or 2048, whatever. But here we see in PQC, like both sizes differs. Like some private keys different size and public keys of different size.
See, actually, in this quantum algorithms, I think there are three stages. One is a generation, one is a signing, one is a verification module. There are three modules are there. So every module, it has its own parameter, the complexity, as well as the iteration mode. So because of this iteration mode, the public and private key which is going to generate it through this pair differs. So that's the reason in quantum computing, the understanding, because it basically, as I have been discussing about the Shor's and Groves algorithm, the symmetric is completely unbroken in the quantum world also. Okay, so in that case, they are mixed matched both the symmetric as well as asymmetric cipher in the quantum world. So that's the reason both the symmetric cipher key size in the private and public key, it's completely different. It's not equal as we saw in the classical computing.
So we cannot expect the size of the private or public key, whatever anyone we can choose the fixed size, the other size may vary.
No, again, that's the reason they are segregated into three levels of security. 2, 3, 5. So it depends upon the requirement and the application need. You can able to go for the complete security analysis.
Okay, thank you.
Thank you, sir.
Thank you, Pandian and Anup.